Okay, my assistant and I are here to demonstrate osmosis. All right, this is an experiment that's going to take place over a couple of days. So tell them what we have here.
Gummy Bear, this, water, and that.
What is this?
Ooh.
Vinegar. Right. Okay, so yes, we have two gummy bears. All right. Just showing them to you so you can see they're normal gummy bears side by side. This is the size. One is going to go into the jar. The other one we're going to hold on to for comparison. Okay? All right, so which one's going to go in the jar?
Okay, it's red.
Okay, put the red one in the jar. All right. Okay, and then we are going to pour a little vinegar in there. Okay, that's good. Excellent work. And we're going to put the lid on it because vinegar is kind of stinky. All right. So the purpose of this experiment is to demonstrate osmosis, and it works this way. All right. We have the vinegar, which is a solution of lower concentration, and we have the gummy bear, which is a solution of higher concentration. So the idea here is that the vinegar will go into the gummy bear, and the gummy bear will get bigger over time. So, but it has to sit for a little while. So we'll check in on our gummy bear in the vinegar tomorrow. Okay, so now we're back about 24 hours later, right? We're gonna check on our gummy bear from yesterday. So what do you think happened to it? What do you think happened to it? So here is our gummy bear from yesterday. All right, so this gummy bear here is the red one on the left. And it got quite a bit bigger. In fact, almost twice, maybe even 3 times the size of the original gummy bear. And that's because our vinegar acted as a solution of lower concentration, and the gummy bear was acting as a solution of higher concentration. So in osmosis, what happens is the solution, or the hypotonic solution, travels to an area that is more hypertonic. All right. So when it happens during embalming, what is allowing to go along with it is our embalming solution kind of goes along for the ride and is able to diffuse into the cells. So here is that kind of in action. So using this vinegar, it looks like we have a pretty well embalmed cell. What do you think? Yeah, of course, right? All right, and of course, normally in science, we don't eat our experiment materials, but what do you think? You gonna try it?
Yeah.
Okay, go ahead. Yeah, go ahead and eat that orange one.
This one?
Yeah. What do you think? Okay. All right. So, see you later. Okay, so my assistant says that he thinks that we should put it in for another 24 hours to see what's going to happen. So go ahead and scoop it up. Put it right back in our vinegar there. All right, and so we will check back in on another 24 hours and see if this gummy bear is even in one piece. Because what might happen is a phenomenon that we know as imbibation. This happens when red blood cells actually take on too much water and cause the protein to break down, and then also become oversaturated and break. So, which is also part of osmosis. So we'll see what happens. And I also can't believe that this kid is eating a gummy bear that's been soaking in vinegar. Okay, we are back now about 48 hours after we put the gummy bear in the vinegar initially. And as you can see, there's not a lot there left. So let's see if we can even get it out of our jar here. It's a ghost of a gummy bear in there. Oh no. See, look at, can't even get anything out of there. It's all vaporized. So over 48 hours, our gummy bear has now completely disappeared. It is now completely disappeared. Sit down. Sit down so the people can see you. Our gummy bear has completely disappeared. Now, what this illustrates, right, as I was talking about at the end of yesterday, is that cells take on the solution of a lesser concentration and then slowly and surely break down through a process called imbibition. That's the taking on of the liquid, and then the actual destruction of the cell is called hemolysis. And so what we have left from that is now an example of how we get postmortem stains. So essentially we have the equivalent to postmortem stains sitting right here in our jar, because our cell has become so saturated that it broke apart into the red color and the globin portion of the protein. What do you think? You want to take a sip?
Yep.
No, you don't.
No.
No.
Yeah.